Hey everyone, welcome back to the College Algebra playlist. In previous videos, we gained mastery over solving linear, quadratic, rational, radical, and absolute value equations. Alright, so now we're ready to move to a weirder type of equation. Alright, equations with rational exponents. Alright, so let's dive into it right now. Okay, rational exponents. Rational exponents are exponents that are fractions. All right, here are a few examples. 27 to the 2 over 3 power is another way of writing cube root of 27 squared. All right, so remember that rational exponents actually represent radical expressions. All right, so here in red, 16 to the 3 over 4, that's another way of writing the fourth root of 16 to the 3. All right, so remember we take the number in the denominator and we take it to the index of the radical, and we take the numerator and we bring it inside the radical, okay? And then the last example, right, 25 to the 1/2, that's another way of writing the square root of 25. All right, so remember if there's no index, right, if it's left blank, it's assumed to be 2, okay? And this whole thing is just being raised to the first power. All right, so this is a brief review on rational exponents, okay? A rational exponent indicates a power in the numerator and a root in the denominator. There are multiple ways of writing an expression, a variable, or a number with a rational exponent. All right, so if I have a to the m over n, right, I can rewrite that as a to the 1 over n whole thing being raised to the m. All right, and that's true because here I have a power on top of a power, right? Remember the exponent rules video. All right, if I have a power on top of a power, I multiply the powers. Okay, so this is m times 1 over n, which is m over n. All right, and because I'm multiplying the powers, I can change the order of that multiplication if I want to. Right, I can bring this m inside and then raise the whole thing to the 1 over n power. All right, and then in radical form, right, this denominator n, right, it becomes the index of the radical, and I can bring this power m inside, or I can raise the whole thing to the m power. All right, it just depends on which one is more convenient, right, which one is easier. All right, so this is the relationship between rational exponents and radical expressions. All right, let's try to evaluate a number raised to a rational exponent. All right, here we're asked to evaluate 8 to the 2 over 3. All right, so we essentially just need to simplify this and see what number we get. All right, 8 to the 2/3 power, right, that's the same thing as 8 to the 1/3 power whole thing to the 2. All right, so this is a power on top of a power, right, so you multiply the powers and you get 2 over 3. All right, and 8 to the 1 over 3, right, that's the same thing as the cube root of 8. Okay, and we know what the cube root of 8 is, right? We know what this expression inside the parentheses is, right? It's just 2, okay, because 2 times 2 times 2 equals 8. All right, so I have 2 squared, right, which is 4. All right, so it turns out that 8 to the 2/3 power, right, this ugly thing simplifies to 4. All right, so that's my final answer. All right, let's try one more. Here we have 64 to the negative 1/3 power. All right, remember from the exponent rules video that if I have a negative exponent, I can make it positive by bringing it to the other side of a fraction. All right, so this 1/3 power, right, this is positive now because it's in the denominator. All right, so I have 1 over 64 to the 1/3 power. That equals 1 over the cube root of 64. All right, and we know what the cube root of 64 is. It's 4. All right, because 4 times 4 times 4 equals 64. All right, so our final answer here is 1/4. All right, so by converting between rational exponents and radicals, right, and using exponent rules, we can turn something ugly into something really nice, right? Rational exponents are ugly. So this video is all about simplifying them and solving equations that involve them, right, that involve rational exponents. Okay, let's try solving an equation with a rational exponent. All right, notice that this is a rational exponent singular. All right, we're starting with just one. All right, but at the end of the video, we'll move to an equation that has two of them. All right, so we can solve an equation with a rational exponent by raising both sides of the equation to the reciprocal of that exponent. All right, we do this to eliminate the rational exponent. A number multiplied by its reciprocal equals 1. All right, so when we raise both sides of the equation to the reciprocal, right, we have a power on top of a power. And in that case, right, the exponent rule says to multiply the powers. All right, and if we multiply reciprocals, right, we just get 1. Okay, so let's try an example. Here we're asked to solve for x, all right, and we have x to the 5/4 equals 32. All right, so to get rid of this rational exponent, right, we need to isolate x, so we need to get rid of the exponent. All right, what we're going to do is raise both sides to the 4/5 power. All right, and we're doing that because 4/5 is the reciprocal of 5/4. All right, so with this power on top of a power, right, we multiply those and we just get 1. All right, we get x to the 1. All right, that equals 32 to the 4/5. All right, and then we can use exponent rules to simplify this further. Okay, 32 to the 4/5 is the same thing as 32 to the 1/5, whole thing to the 4. All right, so in parentheses, we get the 5th root of 32. All right, and we know what that is. We know that that is 2. All right, 2 multiplied by itself 5 times will give you 32. All right, and then we have this power 4 lingering, right? So we have 2 to the 4, which is 4 times 4, which is 16. All right, so our final answer is x equals 16. Okay, let's try one more. Here we have x to the 3/2 power equals 125. All right, so once again, to isolate x and get rid of this rational exponent, right, we're going to raise both sides to the reciprocal. All right, so we'll raise both sides to the 2/3 in this case. All right, and on the left-hand side, right, the exponents are gone. And we have x equals 125 to the 2/3. Okay, let's rewrite that as x equals 125 to the 1/3 power, whole thing squared. All right, in the parentheses, that turns into the cube root of 125. All right, and we know what that is, right? The cube root of 125 is 5. Okay, because 5 times 5 times 5 equals 125. All right, so we have x equals 5 squared, which is 25. All right, our final answer is x equals 25. Okay, next let's move to solving an equation with rational exponents, plural. All right, here we're asked to solve 3x to the 3/4 equals x to the 1/2. All right, so we have two rational exponents, so we're going to have to figure out how to deal with these. All right, how do we isolate x and get a value for it? That's the question. What I'm going to do first is subtract both sides by x to the 1/2 power. All right, what that gives us is this, right? 3x to the 3/4 power minus x to the 1/2 power equals 0. All right, we're going to try to factor this left-hand side. All right, make a transition from terms to factors. All right, and then we can use the zero product property, right, to set each thing equal to 0. Right, if we have something times something equals 0, we can set each thing equal to 0. All right, so before we factor this, let's turn this 1/2 power into the 2/4 power. All right, I'm getting a common denominator over here just to make sure everything has a denominator of 4. All right, it's going to be simpler that way. Okay, so at this stage, right, we're ready to factor. All right, let's factor this left-hand side. All right, turns out that we can always factor the term with the lowest exponent. All right, that's what we want to bring out of this. All right, we'll factor out the term with the lowest exponent. All right, and that happens to be, in this case, x to the 2/4 power. All right, so we pull that out, and we're left with 3 times something minus 1. Okay, remember when you pull out a factor like this, it's essentially a reverse distributive property. All right? So x to the 2/4 times 3 times something, right, when we distribute, gives us 3x to the 3/4. And when we multiply x to the 2/4 times -1, that gives us negative x to the 2/4. All right? So the question is, what do we need to put in this blank here? What goes in this slot? How do we get from x to the 2/4 to x to the 3/4? All right, there's an exponent rule from video 6 in this playlist that we can use. All right, I'll include a link in the description if you need a refresher on exponent rules. All right, this rule says that if we have the same base to 2 different powers and they're being multiplied together, right, we can rewrite that as x to the sum of the powers. Okay? So to get from x to the 2/4 to x to the 3/4, right, we need to multiply by x to the 1/4. Okay? Because 2/4 plus 1/4 is 3/4. All right? That's how we can factor this thing. All right? That wasn't easy, right? The fractions make it awkward and a little bit clunky. All right? But it's okay, we can handle it. All right? Now we have a factored version of our left-hand side. Okay? So we have something times something equals 0, which means, right, when we bring this to the top of the screen, right, that means that we can set each piece equal to 0. All right? So here's what we have. All right, this equation on the left is much easier to solve than the one on the right. All right, so I'm leaving myself more room to isolate x over here. All right, let's start with the equation on the left. X to the 2/4 equals 0. Okay, so we're going to raise both sides to the reciprocal. All right, raise both sides to the 4/2. All right, on the left-hand side, that just gives us x. And then on the right-hand side, we get 0 to the 4/2, which is just 0. All right, so our final solution there is x equals 0. All right, now let's solve this equation. All right, let's isolate the x and get rid of this rational exponent. Okay, let's add 1 to both sides. All right, that's our first step. All right, and then to isolate this x to the 1/4 power completely, right, we need to divide both sides by 3. Okay, so we get x to the 1/4 equals 1/3. All right, and then we need to get rid of this rational exponent, right? So we're going to raise both sides to the reciprocal. All right, raise both sides to the 4 power in this case. All right, and that gives us x on the left-hand side, and that equals 1 to the 4 over 3 to the 4. All right, I'm using another exponent rule here. I have a quotient to some power. All right, the exponent rule says that I can take the power and apply it to each piece of the quotient. All right, so that's exactly what I'm doing here. All right, up top, 1 to the 4th is just 1. And then in the denominator, 3 to the 4, right, that's 9 times 9, so it's 81. All right, so x equals 1 over 81. All right, that's our final answer for the second solution. All right, so this equation has 2 solutions, and we found both of them. All right, so that's how we can solve equations with rational exponents. That does it for this video. Thank you for watching, and like and subscribe.